In this video, the food polysaccharide we are going to look at is guar gum. Guar gum is just one example of many seed gum used in the food industry. Guar gum, which are sourced from the seeds of cluster beans, Siamopsis tetragonoloba, has been grown in regions around India and Pakistan for generations as a food source for both human and livestock. To produce the fine gum powder, the endosperm is separated from the rest of the hydrated guar bean and milled into a white to yellowish white powder. Chemically, guar gum is a high molecular weight polysaccharide composed of the sugars galactose and mannose. The mannose backbone, or specifically termed as beta-D-mannopyranose, is a straight chain with beta-1,4 linkage to which galactose residues are linked from carbon 1 of galactose to carbon 6 of every second mannose. Polysaccharides like guar gum have properties that are determined when subjected to a fluid medium. It is obviously a popular ingredient among food product developers because of its superior properties such as: first, water binding ability or hydration rate. The hydration rate of guar gum is primarily determined by the particle size of powder, hence its variation. Therefore, fine mesh guar gums are accessible for a quick initial viscosity. Second, viscosity building. Guar gum's most substantial trait is its rapid hydration in low-temperature water systems, resulting in highly viscous solutions. As it gets fully hydrated, it creates a viscous colloidal dispersion. Third, hydrogen bonding activity. The presence of a hydroxyl group in the molecule is accountable for guar gum's hydrogen bonding behavior. With cellulosic material and hydrated minerals, guar gum forms hydrogen bonds. However, as hydroxyl groups in guar gums are substituted, steric hindrance occurs, reducing hydrogen bond stability. Fourth, polarity. Dispersion of guar gum results in swelling or dissolving in polar solvents, forming potent hydrogen bonds. But take note, it forms feeble hydrogen bonds in nonpolar solvents. Also, through continuous use and studies of this powder, it was proven that the decrease of particle size and pH has an inverse relationship to the processing temperature, rate of dissolution, and viscosity growth of guar gum. So now, if you're keen enough in checking the labels of your food, especially your pangsiragana, you might find yourself asking, why is guar gum in my ice cream? That's a great question. Because of guar gum's viscosity and water binding ability, it keeps the thickness and the size of the ice crystals consistent throughout what we call freeze-thaw cycle. Through the various stages of production, transport, stocking, and final placement in your home refrigerator, the ice cream experiences periods of warmer and colder temperatures. As your ice cream softens and refreezes, its texture and stability changes, and guar is the key ingredient that keeps the ice cream consistent. That way, the product quality you experience at home is as close as possible to what you find on the production line. So we now know that guar gum definitely is a beneficial polysaccharide because, first, in food and chemical industry, it is used as thickener, stabilizer, and binder or emulsifier because of its ability to make a stable aqueous solution highly viscous at low concentrations. Also, it shows cholesterol and glucose lowering effects because of its gel-forming properties. Third, it maintains bowel regularity, control of diabetes, enhancement of mineral absorption, weight loss, and prevention of digestive problems like constipation. Lastly, guar has significant agricultural advantages because it replenishes nitrogen in the soil and is able to thrive in drought conditions, which makes it an extremely reliable and stable crop. However, this gum also has its limitations, such as when there's high content of water-insoluble impurities, or when it cannot rapidly swell and hydrate, or when the dissolution speed is slow, it results to high energy requirements for food production, hence high cost for the industry. Also, viscosity building of guar gum is not easy to control, which is why it is the responsibility of a food developer and food chemists to optimize the benefits and reduce the limitations of using guar gum in our food product. So to wrap up, in this video, we were able to touch up on a type of polysaccharide called guar gums, its source, structure, properties, uses in foods, its advantages, and its limitations. We hope this video presented you a new perspective into the world of food chemistry. Thanks for watching!